not yet, let's move over to slide number 5, where we're going to look at a little more closely this probability of being left-handed. Again, we're going to break down, like I was talking about, the theoretical probability and the experimental probability of it to see how they're different. Theoretical probability, again, that's what we expect to happen. Theoretical probability is what we expect to happen. The top number, remember, in probability is the number of chances. The bottom is the number of outcomes, or the total options that there are. So yes, there are some people who are ambidextrous who can use both hands, but people prefer one or the other if they're ambidextrous. Most people prefer one or the other. There's only about 1% of the population that is truly ambidextrous that will just use whatever hand is easiest at the time. So we're going to assume that it's just left or right-handed for this information that we're about to do, okay? So this top number, the number of chances that there are, how many chances or how many hands are there for us to use if we're left-handed? 1. We have one left hand that we can use. We're not insects that have multiple left and right hands. We only have one left hand. Out of how many outcomes are there? How many different hands could you write with? You got your left or your right. So our fraction there would be 1/2. You would expect the theoretical probability of you being left-handed would be 1 out of 2. What's 1/2 again in decimal form? 0.5, which is, what is a percent? 50%. Again, theoretical is what we expect. Experimental is what actually happens. So this is a tally chart from a small class that I found online of their hand preference, if they preferred their left hand or their right hand. Now we're going to look at the experimental probability of being left-handed. It's still calculated the same way. The total number of times, though, that something actually happened. Before it was the chances. Now it's how many times it actually happened. So how many times did people actually choose left hand as their preferred hand? One student actually chose it as their preferred hand to write with out of the total number of students. So what is that total number of students for that small class? 10. 10 students in that whole class, one of them actually chose left hand as their preference. What is 1/10? Oh, I read it the same way. 0.1. And what is 0.1 in percent form? 10%. So again, this is one situation where my theoretical and my experimental, they do not match, and they won't always. They don't always match up. I know when I worked at Jimmy John's, not all the sandwiches were ordered the same. The number 9 and the number 5, the Vito and the Italian nightclub, were by far the most frequently ordered options, with the vegetarian sandwiches being the least ordered sandwich for sure. So again, this was just to show you that theoretical and experimental probabilities, even though they're looking at the same thing, they rarely actually match up. They rarely actually match up in the real world. So let's go ahead, go down to the next slide, and we're going to talk about how we would describe this probability. Instead of just giving numbers like that, we're going to turn it into words to talk about the probability.